A spacecraft began on August 5th, 2011, the date on which Juno began its journey to Jupiter's orbit. Jupiter is again the fifth planet in our solar system and differs significantly from our blue home planet in terms of its composition and gigantic dimensions. The diameter at the equator of Jupiter is an incredible 143,000 kilometers. With these oversized dimensions, the planet, which was named after the supreme god of Roman mythology, it is not only 11 times larger than our orbiter is mainly composed of helium and hydrogen. Thus, in orbital astronomy, Jupiter is one of the so-called gas giants, which, unlike the Earth, has no solid surface. The distance between Jupiter and the Earth averages 778.6 million kilometers. It took the Juno space probe almost 5 years to cover this huge distance. On July 5th, 2016, NASA staff were finally able to announce the good news that Juno had made its journey unscathed and had reached its final destination. Since then, NASA experts wanted to find out what the core of the gas giant is made up of. But research into the composition of the surrounding atmosphere is also an important aspect of the space mission. Astronomers also wanted to find out the source of Jupiter's enormously strong magnetic field. But these conditions were not the only phenomena on the giant gas planet that were to arouse the interest of experts. The mysterious mega lightning bolts on Jupiter, distributed according to a conceivably different pattern than we are used to from our Earth. When lightning strikes on our home planet, the resulting radio waves can be measured in the megahertz spectrum. For a long time, however, such measurements could not be recorded in the case of the megabolts on Jupiter. Instead, the impacts mysteriously followed exclusively in the kilohertz range. Another mystery was the fact that the lightning on Jupiter occurred mainly at the north pole of the planet. The unusual flashes on the gas giant also caused headaches for the experts at NASA, because despite all the differences, some parallels between the weather effects on Jupiter and Earth could be reported. According to the experts, regardless of the planet, lightning is a physical phenomenon which, from a scientific point of view, when it whips across the sky of a planet. However, as already mentioned, the signals recorded on Jupiter so far have been in the kilohertz range of the radio spectrum and are therefore in stark contrast to similar observations made on Earth. For a long time, researchers were in the dark as to how this phenomenon could be explained. The technical progress of space travel. However, NASA's current Juno mission could help experts to solve the mystery of the megabursts on the gas giant once and for all. The spacecraft is equipped with state-of-the-art instruments, including the so-called microwave radiometer. This is a measuring instrument capable of recording Jupiter's emissions over a wide range of frequencies. The data collected with the microwave radiometer, MWR for short, has provided important new insights to experts. source that supplies the